What is the area of ABCD? Label points E, F, G, and H. Join G, H. It is a perpendicular line. Let angle C, D, F equals beta, line C, F equals Y and line C, E equals X. It implies that triangle EC, F is congruent to triangle G, HE. This implies that EC equals G, H equals X and C, F equals H, E which equals Y. Since C, F equals B, F, it implies that B, F equals Y. Thus, D, H equals C, D minus C, H which equals Y minus X. Thus, D, H equals Y minus X. Let angle D equals beta but triangle FD, C is similar to triangle GDH. It is side angle side. This implies that y divided by 2 times y equals half, which equals x divided by y minus x, that is equals to sine beta. Cross multiply. Y minus x equals 2 times x. Thus, y equals 3 times x. Y equals 3 times x, we call it equation 1. From 45 degrees, right triangle G, E, F. Area equals the product of line G, E and line F, E. All divided by 2, which equals to 10. Since G, E equals F, E, it implies that area of triangle G, E, F equals the square of G, E divided by 2, which equals 10. Cross multiply and we have that G, E equals to 4 times 5. Take the square root of the equation. We have that G, E equals the product of 2 and the square root of 5. This implies that consider triangle C, F, E. Since y equals 3 times x from equation 1, use Pythagoras theorem. This implies that the square of EF equals the sum of the square of x, the square of y, and the square of 3 times x, which equals 10 times the square of x. Substitute values and we have result to be equals to 20. Since G, E equals E, F for 45 degrees right triangle G, E, F. It signify that divide the equation by 10. Thus, the square of x equals 20 divided by 10, which equals to 2. We call it equation 2. And from equation 1, y equals 3 times x. Multiply the equation 1 by 2. 2 times y equals the product of 2 and 3 times x equals 6 times x, which equals BC. The length of the square ABCD. Then, square the equation as shown. It implies that the product of 4 and the square of y equals the product of 36 and the square of x, which equals the square of BC. Since the square of x equals 2, this is from equation 2. This implies that the product of 36 and the square of x equals 72 squared units after substitution of value of x and simplification of result. Therefore, the area of square ABCD equals 72 squared units. Required to find the area of the red inscribed equilateral triangle. Let base angle of the right triangle be equals to alpha. The relationship of angle alpha to every angle of the right triangles are shown on the figure. Although, we will not use it to solve this problem, but to show you how to get this relationship in case you come across a question involving angle relationship. Alright, let us continue with our solution. Let x be the side length of the square and y be the opposite length of the base triangle. This means that let us find the hypotenuse of each of the right triangle using Pythagoras' theorem. Since the red triangle is equilateral triangle, we obtained an equation for the square root of the right triangles. This is because each of the side length of equilateral triangle are equal and each of its angle equals to 60 degrees. The equation shown on the screen. Equate the first and the second expressions and then square the equation, and we have the sum of the square of x and 16 to be equals to the sum of the square of y and 121. Rearrange terms, combine like terms and simplify, and we have that the square of x minus the square of y equals to 105. We call it equation 1. Also, equate the second and the third expressions. Square the equation, and we have that the sum of the square of y and 121 equals the sum of the square of x minus y and 49. Expand brackets. Rearrange terms, combine like terms and simplify, and we have that the square of x minus the product of 2 and x times y equals to 72. We call it equation 2. Now that we have obtained two equations in x and y as shown on the screen. From equation 2, we have that y equals the square of x minus 72 all divided by 2 times x. Substitute it in equation 1. Thus, we obtained an equation in x alone as shown on the screen. Expand bracket. Combine like terms and simplify. We have a quartic equation in x alone as shown on the screen. For simplicity, let u equals the square of x. This implies that the product of 3 and the square of u plus 144 times u minus 5184 all divided by 4 times u equals to 105. Cross, multiply, simplify, and we have a quadratic equation in u as shown on the screen. Combine like terms, simplify further, and we have the product of 3 and the square of u minus 276 times u minus 5184 equals to 0. Factorize. This implies that after factorization, that the product of the factors equals 0. Thus either u minus 108 equals 0 or u plus 16 equals to 0. Therefore, u equals 108 or u not equals to negative 16. It is because the length measuration cannot have a negative value. Recall that u equals the square of x. It implies that the square of x equals 108. Find the square root of the equation. X equals the square root of 108, which is equals to the product of 6 and the square root of 3. Consider only one side length of the equilateral triangle. Thus, we have the square root of the sum of the square of x and 16. Since the square of x equals 108, this implies that the sum of 108 and 16 equals 124. Hence, the area of equilateral triangle equals the product of the square root of the sum of the square of x and 16 and the sine 60 degrees all divided by 2. Substitute numerical values we obtained and our result equals the product of 31 and the square root of 3 in square centimeters. Therefore, the required area of the equilateral triangle equals the product of 31 and the square root of 3 in square centimeters, or 53.694 in square centimeters to 3 decimal places. What is the length of the blue line? Label points B, C, D, E, and G. Line B, C equals line E, D which equals to 3 units. It is because the opposite side lengths of a rectangle are equal. By trigonometric identity, tan 2 times alpha equals to 2 times tan alpha all divided by 1 minus the square of tan x. We call it equation 1. From triangle EDC, line ED divided by line C, D equals to 3 divided by 4 which equals tan 2 times alpha. It follows that substitute equation 1. It implies that 3 divided by 4 equals 2 times tan alpha, all divided by 1 minus the square tan alpha. Let tan alpha equals y. Hence, 3 divided by 4 equals 2 times y, all divided by 1 minus the square of y. Cross multiply and we have that 3 minus 3 times the square of y equals 8 times y. Rearrange terms. And we have that the sum of 3 times the square of y and 8 times y minus 3 equals to 0. Factorize and simplify to obtain that the product of y plus 3 and 3 times y minus 1 equals to 0. Either the sum of y and 3 equals 0 or 3 times y minus 1 equals 0. It follows that y equals negative 3 or 1 divided by 3. But tan alpha equals y, which equals to negative 3 or 1 divided by 3. This implies that tan alpha is not equals to negative 3, as alpha is an acute angle. It signifies that tan alpha equals to 1 divided by 3. By trigonometric identity, the sum of 1 and the square of tan x equals the reciprocal of the square of cosine alpha. Substitute values and we have that the sum of 1 and the square of 1/3 equals 1 divided by the square of cosine alpha. Simplify so that 1 divided by the square of cosine alpha equals 10 divided by 9. Cross multiply. The square of cosine alpha equals 9 divided by 10. Take the square root of the equation. It implies that cosine alpha equals 3 divided by the square root of 10. After simplification, we call it equation 1. From triangle G, B, C. Line B, C divided by line C, G equals cosine alpha. Then, substitute values of equation 1 and line B, C into it. It implies that It implies that 3 divided by line C, G equals to 3 divided by the square root of 10. Cross multiply and we have that line C, G equals the product of 3 times the square root of 10. All divided by 3, which equals to the square root of 10. Therefore, the length of the blue line equals to 10 units.
Consider the given figure. What is the value of the angle with red label? Label A, B, C, D, E, and F. Let line A, D equals to Y, which also equals to line C, D. It implies that line B, C equals Y. By Pythagoras' theorem, the square of A, B equals the sum of the square of A, C and the square of B, C. Substitute values and we have that it means that the sum of the square of 3, 5 and 4 equals the sum the product of 2 and the square of 2 times y. Thus, the square of 12 equals the product of the 2 and the square of 2 times y. Find the square root of the equation and simplify. We have that 12 equals the product of 2y and the square root of 2. Solve for y. Signify that y equals the product of 3 and the square root of 2, which equals to the square root of 18. From triangle ADE, let angle AED equals alpha. By using cosine rule, we have that the square of line ED equals the sum of the square of 4 and the square of y minus the product of 8 times y times cosine 45 degrees. But y equals the product of 3 and the square root of 2. Thus, after substitution and simplification, we have that the square of ED D equals the sum of the 16 and 18 minus 24, which equals 10. Find the square root of the equation. We have that the length of line E, D equals the square root of 10. We call it equation 1. Also, in the same triangle using sine rule, line E, D divided by sine 45 degrees equals to Y divided by sine alpha. Substitute values and we have that the square root of 10 divided by sine 45 degrees equals to the square root of 18 divided by sine alpha. Cross multiply and solve for Y. We have that sine alpha equals 3 divided by the square root of 10. From triangle AFD. Use cosine rule and we have that the square of f, d equals the sum of the square of line AF and the square of y minus the product of 2y line AF and cosine 45 degrees. Substitute values. Thus, the square of line F, D equals the sum of 81 and 18 minus 54, which equals to 45. Find the square root of the equation. Thus, line F, D equals the product of 3 and the square root of 5 in units. From triangle DEF, let angle DEF equals beta. It implies that beta equals 180 degrees minus alpha. Use sine rule, we have that line F, D divided by sine beta equals to line E, F divided by sine D thus. Substitute values. Thus, we obtained equation as shown on the screen. By trigonometric identity, sine angle of the difference between 180 degrees and alpha equals to sine alpha. But sine alpha equals the product of 3 and the square root of 10. We obtained it earlier in our solution. Hence, we substitute this value in the equation, the square root of 45 divided by 3 divided by the square root of 10, which equals 5 divided by sine d. Cross multiply and solve for sine d. It implies that sine d equals 1 divided by the square root of 2 after simplification. take the sine inverse of the equation, and we have that d equals the sine inverse of 1 divided by the square root of 2, which equals to 45 degrees. Therefore, the required red angle equals 45 degrees.